Okay, welcome back to part 2 of the Arcology Roguelike development that I'm working on. Just a quick overview of where we were. We were looking at some of the design process that we're going through. We looked quite a lot at the high concept, what it is that trying to build. Actual concept of this game is the idea is that it's some kind of arcology, which is obviously a massive building, this massive city. There's a dystopia, cyberpunk kind of feel to it. We also want to make it a squad-based game. We'll be thinking quite a lot about that and working quite a lot around that as well. And then looking at the idea that it has to be a roguelike as well. I'm just quickly going to pause. Just want to fix something on the stream. Okay, hopefully that'll be a bit better. Stream was just a bit slow there for a moment. So just to recap, the big idea is to create this roguelike game, place this roguelike in a massive city building, and the whole idea is that this city that this building that we'll be creating is going to be procedurally generated. So that's what I want to focus on quite a lot today, if I can, is the actual procedural generation. A couple of things just in terms of the stream itself. I've tried to fix some stuff with the sound, so hopefully the sound will be better. And working on 2 screens while trying to chat to the camera makes it difficult to always keep up with the chat. So I've just popped up the chat window here on the side. So obviously whatever you say will pop up over there, but that should make it a little bit more obvious to me if anybody wants to join in and make some comments. Megan was here earlier, and I'm sure she'll hopefully pop in later again with a lot of comments about my design, my narrative, and all those good things that she knows quite a lot about. So we want to look at procedural generation. So what we did yesterday when we looked at it last time is we worked on this card. We talked about what we want from our procedurally generated levels, and then we talked about some of the techniques that we're going to be using. So the main thing we want is an increase in difficulty at a correct pace. Should start out relatively shallow slope, if you think about plotting out the difficulty curve, but get more and more difficult quite rapidly as the player becomes more accustomed to the game as well. Very importantly, we want levels that are tactically interesting, things that allow you to flank an opponent, destructible terrain. The actual layout of the level should be interesting. You shouldn't just be able to or need to grind to a high power level or just grind until you get exactly the correct loot. We want to reward clever play and interesting play as well from our players. We want our levels to feel somewhat unique, which is quite difficult to do with procedural generations. And we also want to have this dystopian aesthetic. So the techniques we're going to use to get that right, things like cellular automata, which will hopefully give our levels a bit more of an organic, slowly broken down, rough feel to it. We're going to use Perl and noise to create specific defined areas, and we're going to use a template approach to create some kind of original structure. The idea being that our buildings were created as this massive structure with a very specific ideal, and it started from that, this template approach, where you've got a layout of specific rooms or specific areas, and then it's slowly decayed over time. And then that gives us our final level design will be our template approach plus our polar noise plus our cellular automator. So what we want to do is to create a small little prototype and get into the actual live coding as promised by the stream name and the channel name. Start out with that, this prototype, which we can then also convert into our main game. So we might not get proper models working, but we want to see if we can get this idea of templates working as well. Probably be the first part and the only part that we'll be able to properly finish off today. So if we can get some rooms, for lack of a better word, going, rotate them a bit, work around with them, get them to be randomly generated, then we can later on add the other stuff to it and get to our final level design. So that's what we're aiming for. So I'm going to create a small little prototype in Unity, which I am going to, I don't know if you pressed a number key, it actually adds a label to it. Interesting. Thank you, Trello. We're going to create a small little Unity application, and that is going to actually allow us to test out some of these things. Prototyping is also about testing. We don't just want to just build and just actually do development work inside there, but actually test out ideas and test out things that might lead to better options in terms of our overall design as well. Okay, so let's have a look at creating a small Unity prototype to do our level design. So open up Unity Hub. We are going to be using Unity 2019 for this. It doesn't really matter, but I'm going to make it a 3D application, and we're going to call it Arcology Roguelike Proc Gen Prototype. It's a very long actual name for our little prototype, but at least I don't know exactly what it's going to be. Okay, so while that's just loading up, we want to think a little bit about what are the kind of things that we are going to need to have within our basic template or basic room. We're going to start with some basic objects, build up from there, and then make it expandable. So we need to think about flexibility, future enhancements. We need to think about the idea that our game as a whole should be something that the idea behind it is that it will be probably an open source game, so that other people can play around with the code, change the levels, change level design, and do a lot of things like that. So we want to keep that in mind as well. So we're going to start out with just by trying to make this as easy as possible, and then build on from there. This is Unity. What we want to kind of build inside here is a very basic generator for some levels. And the whole idea that we want to work around is the idea of templates. So if we go back to our procedural generation card over here, we've got templates that we want to work with. So the idea is that there are going to be certain defined templates, and we can smush these together, add these together, kind of like bits of Lego bricks, and then go from there. Let me see if I can do that. Is that better, Megan? Just try and sort out the volume over here a bit. I'm going to carry on for now, so we don't have like this awkward pause. But please let me know if that's a little bit better and a little bit louder. Unless, of course, if you can't actually hear me, then this doesn't really help. Okay. So, what I want to do is I want to create essentially a template that I can work from and that I can easily change. That's good news. Let's just remember what I did. Want to create a template that I can easily change later on, that I can easily update, and other people can easily update as well. This is a very long-winded way of me for me to say that I actually want to create my templates as files. If I've got files that are easily editable, I can easily actually change the structure of the game without having to rebuild it and work from there. So what I'm going to do is I'm going to create a new folder. We are going to call this scripts, and inside the script I am going to create a scripts folder. I'm going to create a new C# script, which is going to be procedural generator. Okay. The idea behind what I want to do with my procedural generator script is actually to have it not be a Unity script itself, but rather just a normal C# file, normal C# class, which we will be able to access from Unity itself. The idea behind this is that our procedural generator will run on its own. Once it's done, it will bring back and give back an actual map of the new level that we've created to the actual game, and then the game in Unity will convert that into something that makes sense in terms of assets, 3D models, those kind of things. So what we want to do very importantly is separate out our actual procedural generation logic from the way that we're going to display it in Unity. There's a couple of reasons for doing this. One of them is that we are not entirely sure exactly how we're going to be displaying it in Unity. And we want to keep those separated so that we can very easily switch out different displays. And also the procedural generator, we want it to be something that doesn't come with all the extra baggage that Unity provides in terms of the mono behavior. We don't need to worry about where this procedural generating class is working as a game object, where it's placed. It's all about just generating a map for us. So what we just need to think about in terms of what we need to do is really what are the different things that we're going to need. We're going to need some properties to access and handle the basic things that the procedural generator will do. We're going to need some methods to actually generation methods to actually generate it, and we are going to think about what kind of structure this or pattern this procedural generator is going to follow, this class is going to follow. So we'll just pop back to my card over here. The idea is that we want our procedural generation to be built up of 3 parts, and we're going to be building it up bit by bit by bit. So first the template, then the pillar noise, then the cellular automator. So this idea of building leads us to the idea of the builder pattern. Now the builder pattern is a design pattern where you generate a class, but it's especially useful if you don't know everything at once what you're going to generate. So you can generate it piece by piece by piece, or bit by bit by bit. So we're going to have methods for generating the different properties, the different sections that we have, and as we go through that, we're going to add them all together. So that's the process that we're going to take. Okay, we're also going to need a, for lack of a better word, output method, which is going to tell us or return the actual result of our procedural generation. And then we'll also need an input method, which really is going to be where our templates are going to be coming from. Probably going to be reading from a file or something like that. Okay, so those are all the different things that we need to do. Let's get to that then, and let's start building this procedural generator. Want to get as much done as possible, so that we can actually from this start putting something into Unity as soon as possible. So the properties that we're going to need is going to be a 2D array. So our 2D array is going to be what I'm going to call level. And we need to define how or what this level is going to actually store. So it's going to be a that didn't work well. Let's try that again. Make it an info now, because we can always go and change it. Basically, we want a 2D array or a 2D map, which is going to define what our entire level is going to look like. The easiest way to store this is probably going to be as a whole collection of integers, and where each integer is a possible tile type. So the idea is that each level is made up of a whole bunch of tiles, and each one of these tiles could be of a different type, and we use an integer to actually store the different tile types over here. This is fine, except there's a slightly better way in which we can actually do this. We can actually define our tile types as something a little bit better than just a integer. We can use an actual enum. So an enum is just a named list of options that something can be. And this works fine for procedural generation. When we create our initial level, each tile, each square, each block, whatever you want to call it, can only really be one kind of thing. Eventually, there could be an enemy on that. There could be an item to pick up. There could be the hero characters or player characters could be there as well. Eventually, there could be a lot of different options over there. But what we want to do initially for the level is each tile, each block can only have one thing. So that makes an enum quite nice, because we basically just create a list of what all of these are. We can start with a very basic empty enum and then go from there. The other thing that's very nice is that our enums are also organized as integers, starting from 0. So our very first enum is internally stored within C# as the value 0, and if we were to read a 0 in from a text file, we could then very easily convert that into an enum. So that allows us to work with integers in the background, but for us as the programmers, we can use our nice tile type, which is just easier for us to understand what's going on. So we'll start with an empty tile, An empty tile in this case is a tile where something has gone wrong. Something has gone wrong in our code. It's not supposed to be empty, but there's nothing there. So we don't want to have any nasty null pointer exceptions or anything like that. We just want our actual code to work even if we make some kind of mistakes. An empty tile is just there's nothing there. Something is wrong. And we can know once we start actually linking this to the 3D models, we can place some kind of 3D model there that will show something has gone wrong. Very useful for testing as well. We want to get our procedural generator up and running as quickly as possible, so I'm not going to define too many tile types right now. We probably need to add another little to-do item over here where we've got tile type definition as a part of one of the things that we need to do. We might be getting some much long-awaited rain, so you might hear some thunderstorms in the background. Please don't be too scared, but if you hear any funny noise in the background, that's what's happening over there. So we're going to eventually define a whole bunch of tiles that we want, but let's just go in there and define a couple over here. A floor tile, which is just an empty floor. That's still an actual floor, but you can't walk over. A wall tile, a door tile, and what I'm going to call a crate tile. So this is some kind of crate that is within our level design. Now, at some point we need to start thinking about what in our actual game is part of a level and what is inventory, and what are units, and what are things that move around and things that don't move around. But we just really want to get a hang of what's going on. So let's just create these things as the basic things that we want to create. And what I'm just going to do is also just not press escape, because that's a horrible idea. Just define what number they are as well. Very easy for me just to reference later on. So those are our 5 tile types that we have. So we can then just go back to Unity. I'm not going to add the numbers for all of them. We can always refer to that later on, but we will then just define these different options of what a tile could be over here. The crate in this case is obviously just some kind of your typical gaming crate that we can work with. So this is our level, and it's made up of these tiles. This is obviously just a start, but this should give us an idea of what a tile, what an entire level is going to be like. So the idea behind this is that we are going to have, when we are generating a level, this will be the final value that we generate, the final outcome. But we will also probably need to have a collection of all the possible templates that we can create. So we are going to create a list of tile type 2-dimensional arrays. And these are going to be mini levels, or as I'm going to call them, room templates. So we are going to define a whole bunch of possible room templates, and from them we are going to actually be able to build and create a level. So what does a room template look like? And this is where we need to start thinking about what we're actually going to be doing with our game. So what I'm going to do is I'm going to create a new file. We're going to create it in the root folder so that we can actually access it in once Unity runs. Unity generally looks for files within the root folder, not the folder where the actual script is. And we are going to call this, actually let's just neaten it up a bit. We're going to create a new folder which we're going to call room templates. Inside room templates I'm going to create new files. I'm going to call it room1.txt. It's just going to be a text file, nothing too complicated, but inside here we're going to define what a room looks like. Now there's a couple of ways in which we could do this. Very naive kind of ways to think, well, our floor would be 1 and our wall would be 2. So if I were to create a bunch of 2s and a bunch of 1s, and place a door or 2 door tiles somewhere in the middle, I could define a room quite nicely. And this approach, while it would work, has the obvious problem of if we ever get beyond 10 rooms, it's not actually going to display properly. So, and the idea is eventually, because we want to have enough complexity within our game, we want it to be interesting enough, we're probably going to have more than 10 tile types. We really don't want to force ourselves into kind of a Y2K problem where we limit the amount of numbers that we can use. We don't just want to keep it to 10. So what we're going to be using is a bit more of a different format, which is generally known as a comma-separated format. Sorry. Talking is quite makes me quite thirsty. So what I'm going to do is each tile is going to be separated by a comma. So this means I could have a whole bunch of numbers in here, and we could have any one of these numbers being above 10. So if there's a very special kind of tile, maybe tile 88, which has got a very special definition, we can even place that in our room as well. We're not going to do that. We're just going to have this kind of structure. The nice thing about the structure is that it is quite visible, quite easy to see what's going on. It does have the disadvantage that we are wasting a bit of space. It doesn't compress that easily. So we could eventually update this so that it becomes a more efficient structure, but it's fine for now. I'm going to create one room, and I'm just going to make sure that I've got all the different kinds of objects I want inside there. So if we go back to our definition, 0 is empty. We don't have any empties. Nothing has gone wrong. We've got some floors, we've got some walls, we've got the door. We want to add some crates as well. So let's just increase the room size a bit. Add 2 crates in the middle of our room, and then also define our door as a 1 space big door. Now there's a lot of things that we need to keep in mind in terms of how big are these tiles, what does this actually mean, and once we start building the 3D models, this will become a little bit clearer. At the moment we just want to create a prototype and see if we can get it to work. So what we need to do is this kind of thing needs to be defined and read in by our actual procedural generator. So our input method is going to have to do that. It's going to be public load templates, and probably a good idea over here to give it a path that we want to load from. It's going to be a void method because whatever we load will be loaded into our room templates property that we can work with. Our generation method is going to be a couple, but we're going to start with our basic constructor. We just need this because we want somewhere to start from. It's public. Let's create a new procedural generator, and what we probably want to define is the size of our actual level. Okay, so we've got a width and a height. We probably want to actually define that inside our procedural generator as properties as well. So we've got a width and a height that we've defined, and to properties, so we can access it from any other classes outside of this class, which would be whatever we're going to be using to be displaying this actual level that we've loaded. This is going to be our constructor. We're going to set some values inside there. The main thing we're going to be setting up is that our width is equal to the width that we pass through as a property, and our height is equal to the height that we pass through as a property. Okay. What I'm going to do with the width and the height, I'm going to make them read-only properties, so that you have to define them through our procedural generator. That just means we don't have any funny surprises that our width and our height gets changed halfway through. That's all that our procedural generator constructor is going to do for now. Is it's going to actually just set the width and the height, create a new procedural generator, and then from there we need to also then actually start doing the rest of what we need to do, which will be loading the templates and then generating our template-based initial structure. So if we go back to our design, this will be our initial template approach, creating our original structure. So we'll have a public void method for that. It's void because it will be creating it on the tile type, and what it will be doing is generating initial structure, which it will be doing from our list of templates. You're probably going to have to pass through some parameters eventually about how many rooms we want to generate, all kinds of things like that, but we will get to that as we work through the process. The generating initial structure will then obviously just had a bit of a slow moment there. We need to make sure that the load templates happens first, and then the generating initial structure needs to happen. So we need to start thinking about testing and things like that as well, but we will eventually get to that as well. So we probably want to create an exception handling system for this procedural generator eventually as well, which we will do later on. So generating the initial structure, I'm just going to add it in comments over here, will, nice to do anchor so that we know what we need to do. add together a number of random rooms in a random collection randomly. Lots of randomization which is going to happen over here at this point. So what we have to keep in mind is that we are probably not going to have some kind of perfect room template or room structure the first time round. What we're probably just going to do is take a bunch of room templates like what we've defined over here and kind of just smush them together. But first, let's actually get some room templates. So let's see if we can do that. So what we need to be able to do is to read in a whole bunch of different room templates and then go from there. So what I'm going to use is a method from system.io. Which is file dot read all lines. Okay, I just had to remember exactly what that was. Let's just see what that returns. So what file that read all lines it does, it reads through any take a file that we pass through, it reads all of the lines, each line being one line in an array, which would give us this kind of structure. What we then just need to do is take each individual line and split it up so that we can get a 2D tile type array. So what we want to do is for each line in lines, we want to do a line dot split where we split it on our separator, which is a comma. That line dot split is then also at the end of the day actually we've got one interesting thing that we just need to define. We can declare it, but we actually need to define what size it will be, which we'll only know once we've actually read in all the lines and the length of one line. So we are just going to actually move that to be before our for each. And we are going to define a height and a width. So we're going to be working along the our first value being the x-axis, which would be along this axis, and the second axis being our y-axis, which is then actually our height or our vertical axis. So we can get our x-axis from lines dot length, and we can get our x-axis from the length of our first line, and we can get our y-axis from the length of all of our lines, the actual length of that array. This does mean that we are sorry, we just need to put these in the right place. That's what I had. Okay. Sometimes the red squiggly ones just take a while to go away. So this should create a new temporary room template with the size and width that we want. This just we assume that all our lines are of the same size, i.e. rooms are rectangular. We won't have any lines that might be weirdly shorter than another room. That does not work for the kind of structure that we are building. If that is something that we eventually want to change, we are going to have to change our load template method. But that's why we've put it on its own. We should be able to very easily just add it or update it as needed. Okay, so we've got our temporary room template, which is going to be a whole bunch of tile types, which we can actually create. What we now want to do is to read through our text file, take each one of these numbers, convert it into an actual tile type, and see what we can do with that. So to be able to do that, we probably need another loop, though we should be able to do this as one line. We also just need to keep track of where we are within our actual the number of lines that we've created. So numLine is just going to define how many lines we create, so that we can do something along the line of tile type numLines is equal to tiles. You're going to let me do that. Okay. I'm going to need to use another for loop over here. So at this point we start thinking something's probably getting a little bit as we like to say, something is smelling in our code, but this is fine for an initial development. So we're going to go through each line. We're going to split that line up into tiles. We're going to go through each one of those tiles, and then what we're going to do is we are going to cast, and this is where the fun magic or the enum comes in. We're going to say take that tile, which is a number, and cast it to a tile type. So I put that in normal brackets to do the cast. Obviously we need to cast it to an integer first. is not available because we don't have a console application. Sometimes you quickly just need to ask the Googles. See if that works. Parsing 32 is in fact a part of the system namespace, so I just need to add that over there. This might seem a little bit complex what we're doing over here, but we're taking our tile, which would be a string, we're converting it into an integer and then converting that into a tile type. So long there are no weirdnesses going on in our actual rooms, this should work fine. Each time we do this, we need to increment our number of tiles, which will then get reset after we're done with the line, and each time we do it with the line, we need to increment our number of lines as well. Okay, quite a bit of complexity there, but that gives us the ability to create rooms quite quickly and easily for us to actually use. So really what we want to do is we want to see, does this thing actually work? What I hate doing when I'm coding is writing too much code with actually testing it in some kind of way. So what I'm going to do is I'm going to link this to Unity. I'm going to link it in a very basic way. I'm going to create an empty game object, which I'm going to call level. I'm going to add a new script to that, which I'm going to call level generator. I'm going to add that, that's great. Make sure it's within my scripts folder as well. Open up level generator and just open up level generator. In our start method, we should be able to create a new procedural generation object. So because they are in the same namespace, procedural generator, which is our class, we can access that. We're going to create a new procgen. We're going to keep it private because we only want to access it internally. Publicly, we want to have a width and a height, because we're going to need that when we actually define our new procedural generator. Okay, and then what we can do is call procedural generator dot load templates. We need to give it a path. At this point, I'm just going to hard code it as room1.txt. Once we've done that, this should now be loaded into our room templates, or into our temp room template. What we just need to do after we've loaded one template, we just need to add it to our current room templates. So we can call load templates multiple times with multiple files, which is great. We can even make it so that it loads all of the files in a specific path, which we might eventually get to. So our room templates should have at least one template inside there. So a very quick and dirty check that we can do is a debug.log procedural generator dot room templates dot count. If we get any errors with that, we know that our procedural generation hasn't worked, and then we can try and backtrace to find out where it is. Okay, let's just save our scene. It should be displaying in our console now. Okay, can't find the file room1.txt. You will see us looking for it in the actual root folder. Let's just open up. I'm going to close room1.txt over here. This is just something that you always need to keep in mind of where exactly is your actual files, and I've gone and lost it now. It's on the room templates. Okay, so I'm just defining a actual specific path for our room template. Let's stop that. Clear that, and actually forgotten I'd created that room template folder. Stop it, run it again. And it's outside the bounds of the array. Okay, that is interesting. At some point we're trying to pass something that we should not be able to pass. Okay. So what is happening is that when we define the size of our room, we are looking at the actual number of characters, which in this case is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But our actual room template has only space for all the rooms that are inside there. So what we just need to do is to do a temp split to get number of characters, number of tiles in a line. We take our very first line, we split it into a temporary variable, and then our should be temp dot length. Temp in this case is an array of all of our tiles that have already been split by a comma. Okay. into some issues. We should still be able to debug. Yeah, we can still debug some stuff over here. I'm going to debug temp dot length and lines dot length. This is just going to give us an idea of if I'm reading in my files correctly. Seem to be having bad luck with passing through text. 6 and 5. Okay. 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 3, 4, 5. Okay, so our sizes that we are getting for our actual procedural generator are correct. I've just gone and screwed up my number of tiles and my number of lines. Basically my X and Y axes, which is something which I was very, very careful about. I keep very easy to get confused between those. Okay, Control S. Let's clear that, run that again. Because we're getting a different error, which is always encouraging. Object reference not set to is object. Room template. Our room templates is a list, so we just need to define it as a new list of type type 2-dimensional arrays. Okay. I did mention last week that I want to start with the procedural generation because it's some of the more complex stuff, and as you can see it gets quite complex. We have got one. Very happy to see one over here. One means we've got one single template in our array. So before we get to generating our initial structure, let's just use our level generator to display one template. So what I'm going to create over here is a display method. And what it's going to do is it is going to loop through each tile in our generator. Based then on the type of tile that it is going to then actually generate a 3D model. Okay, so we are going to get some 3D stuff showing. So what a naive implementation of this would be something like, and this example is just an example of displaying a template. Let's actually just make a display template class so we can just Mostly we'll use this for testing. So that we can have another class which is going to separately display the entire level for us. So I'm going to create a tile type array which is going to actually be one of the templates based on the number that we pass through. So it's a list starting at 0, so if we pass through template number 0, it should display the first template for us. And what we're going to call this various is going to be template. Okay, so in our start, we're going to load the template. We're going to first create a new procedural generator. We're going to load the template, and then what we're going to do is we're going to display the template. This seems like quite a lot of effort, but it is worthwhile at the end of the day. So because it's a two-dimensional array, we need to define and just pass through which dimension of our template we want to get through. And then a couple of things are going to pop up over here, but we'll get to them as we get them. We're going to use Z so that we can actually display our objects within the XYZ coordinates of the Unity world. If we just think about that, X and Z on a flat plane, Y is height. At the moment, our levels are flat levels that we've defined. So just so that we don't get confused, we are going to be using X and Z over here. So what would we want to do? Well, naive implementation might be something like, well, if template X comma Z is equal to tile type dot empty, then we instantiate a new empty prefab. So, and then we do an else for all the other types that we have, which is fine, but we want our code to be flexible. We want it to be able to work with any number of file type. We want to be able to update our number of different types quite easily. We don't want to be adding onto this massive if statement the whole time. So what we can do is we can take our template and convert it into a number. So we can actually say instantiate something probably from some kind of array. So, and then just choose a number from that array. So if we've got an array of prefabs which starts at 0 and follows the same structure, we can very easily actually pick one of those numbers and do something like tile prefabs template, because template is actually a number at this point, and then all the other information that we want. So we just need to set up tile prefabs. So what I'm going to do is I'm going to add one more public game object here, but it's going to be an array of game objects called tile prefabs. So any 3D models we create that we actually want to display as tiles will be part of tile prefabs. This will obviously be temp x comma z. The template itself is still of tile type, so we just need an explicit conversion to int over there. Hey, that works. And now this allows us to create a new vector x 0f and then we also just need a rotation. Okay, so this one little line of code over here will allow us to generate any number of prefabs so long we've actually created the prefabs and added them to our level generator game object. So how does this all fit together? Well, if we go back to Unity, we look at our level, we'll see we've got a width and a height. At the moment, that is not actually going to make a difference because we are just going to be displaying a template, so we can ignore those. But we've got a tile prefab, which has got a size. So we want to create game objects equal to the number of possible prefabs we have. So 0, 1, 2, 3, 4. So because it's only 0, the total number there is 5. And that gives us 5 elements where we can quickly create some game objects. So quickly just going to do that. And these are obviously just some test objects. Hopefully eventually be able to get some proper 3D models inside there. Just create another folder for the materials. Just create some brownie material for the walls and the floor. Let's create a gray and relatively shiny. Needs to be a little bit more gray. Metal kind of texture, and then just so that we can brightly, nicely see them, I'm going to create a bright red texture, which we can use for things like the crates. Okay, so we've got our different textures. Let's create some prefabs. I'm going to create them in the world, and we are going to create them on the idea that one unit within the Unity world, a 1 by 1 by 1 cube, is the same size, or a 1 by 1 square on the ground is the same size as a tile. We've kind of been skirting around the issue of height of here for a bit, but we will actually get around to that, hopefully at some point, to figure that out properly. Some interesting comments. Well, I suspect somebody might be pulling my leg. If not, hopefully I'll be learning something new. I was waiting for Megan to make some comments about the errors in my code. There's a lot of errors in my code. So we're going to start with a very basic idea of a cube that is of height 2. And starts, we're going to keep the y at 0. Let's move the y up. And is colored brown is a wall. And we add that to our collection of prefabs. Let's duplicate that, delete that, unpack the prefab, make it a floor, make the 0.25, make that position 1. Might need to play around with the positions a little bit, which is always really frustrating. And the really frustrating things in Unity. So what we just want to define is we want to define our floor and our walls in such a way that if we all place them at the same height, they will be placed correctly. We've got a floor, we've got a wall. Delete that. Let's duplicate our wall, turn that into a crate. Sorry, turn it into a door. Any distance between a wall and a door is going to be the material. Just need to unpack it. Okay, it is there, just hiding. Drag that into our prefabs. And finally, take our wall, duplicate it, create our crate. This size is going to be 1, position is going to be 0. Delete that, unpack the prefab, spell crate correctly, get our material onto that, nice and red, and then drag that into our prefab, actually into our prefabs. So we've got crate, door, floor, wall. What I just want is one final prefab, which is obviously our empty object where we want to show something has gone wrong. Hopefully we won't have any of them, but we just want to make sure that if we do, it is going to be fine. So I'm just going to create a new material for that. And what we're going to do is use a very bright pink for that. And this will indicate to us that something has gone horribly wrong, but we will still actually be getting prefabs, something to show at least. Okay, created these objects in the scene so we can just see them. What I'm actually interested in now is adding all my different elements to my prefab array over here. So the first one is an empty element. We just go back to our tile type definition. It's technically something we're working on. 0 is empty, 1 is floor, 2 is wall, 3 is door, and 4 is crate. So we don't have any rotation or anything like that, but we should have something in place. Now we are getting it to the point where I'm pretty sure something is going to go horribly wrong, but let's have a look at that. Level generator should display and instantiate some stuff for us. It should base it on the tile prefabs. Load template seems to be loading it correctly. If it's converting it correctly over here, that's going to be the real question, and if that is something that we can see. So let's hold thumbs and see if that works. And lo and behold, we have got a template. It's not looking like much, but we've got a very clear door over there. We've got walls all around. We've got some crates in the middle as well. I'm in the scene view because our camera is not really set up yet to move around or do anything too strange. So, think about this. This is actually kind of cool. If I want to add any more models, I just need to increase my my size over here, add them to my list over here. And these horrible models I have at the moment can be updated to be actual proper 3D models, which is obviously eventually what we want. We've created these objects in our actual world. At the moment, all our walls and doors are individual objects, which is obviously not very efficient, but one of the things that we do want is the possibility that these will be destructible. So I'm going to leave it as it is now, so that eventually we can add some logic that you could actually destroy individual walls with explosions or different kind of mechanisms as well. So hopefully that's something that we will be able to do. So we've got a template in place, and we've also got the ability to display that template. What we really want to do now is just to create a whole bunch of these templates and kind of create them randomly within a map of a certain size. So we don't always know that we will need to add some logic to make sure that rooms and templates are put together with other rooms and templates that make size. But for the moment, we can use a little bit of an interesting process where we can just randomly pick a spot that is within our height. I'm going to define a variable over here, which I'm going to hard code for the moment. Just because we're running out of time for today's session. But eventually this will be something that will be read from our actual file. So what we're going to do, and this is a little bit of a hack, but we're going to say within the bounds of our width and height that are given, we are going to randomly create a number of rooms. So let's say int num rooms. And this is obviously not a final algorithm. This is just to kind of play around with the idea of using templates to actually create rooms. Use Unity's built-in random for this. Okay, spelling is going to be horrible over there. We're going to randomly create a number of rooms, and then what we're going to do is sorry, this is just needs some thinking. Room templates is a list, not a array. So we randomly going to choose one of our room templates. We only have one. And then what we're going to do is we're going to take each single character or tile in that template, and we are going to copy it into our we're going to copy that into our actual, what do we call this thing, our level itself. This is probably not going to work properly. So we might just give it a go to see how it goes, and then leave it at that. But let's, instead of this, we haven't created a display for displaying everything. I'm honestly going to call it a night over there because I'm getting a little bit tired and it's getting a little bit late. But what this code will be doing is it will be taking a certain number of rooms, putting them all together, putting them into our level based on random room templates, and then placing them. We will probably need to add quite a lot of logic over here. That the rooms don't overlap, which is probably something that we might or might not want to do. So this is all some stuff that we need to do, but at least at the moment we've got a way to actually read in different templates and to display them, and we will be able to very easily define a new template. So just to show off that, and hopefully this works, let's just change our room's actual layout. Run this again, and we get a different looking room with out the crates that are inside there. But that would at least give us the structure now, where I can define a whole bunch of different kinds of templates and put them together. The putting them together bit, which I've started on over here, is what I'm going to be doing in a little bit more detail in the next session. So hopefully that was interesting. Hopefully you guys found something useful from that. Megan wants to see it run. It runs perfectly, Megan. We just it's only showing one template and not an entire room. I think the stream cool. Yeah. Can look into the past and see what my stream was like. But hopefully that was interesting. I really need to take a break from this, but we'll carry on and do some more stuff in a bit. Hope you guys enjoyed that, and chat again soon. Cheers.